online lesson on the chapter of air. As you know, air is all around us, and you might be wondering right now why is there a need to learn about it. So in this chapter, we are going to explore two key questions. Firstly, what is clean air made up of? And second, what causes air pollution and what are some of the effects of air pollution? As you know, air is a mixture of various gases. So the two main gases in clean air are actually nitrogen and oxygen. In addition to that, there are the noble gases, which consist mainly of argon, as well as other gases such as carbon dioxide and water vapor. So together, these four main components of air are as such. So the different gases are present in different percentage compositions. For instance, nitrogen occupies about 78% of clean air, whereas oxygen occupies about 21%. Therefore, these two forms the main gases in clean air. Noble gases, which consist mainly of argon, occupies about 1%, whereas other gases such as water vapor and carbon dioxide occupies about 0.03%. So, how did scientists know about these percentage compositions, and is there a way to separate these gases? The answer is a definite yes. So to do so, we have to first condense gaseous air to obtain liquefied air. Liquefied air is then separated using this technique that you see over here into the various components. Do you still remember what is this setup called? Yes, as some of you may recall, this setup is called the fractional distillation. But do you still remember how are the various components being separated? The various components are separated based on the different boiling points. As you can see over here, the different gases have different boiling points, which allows them to be separated at different times. So this is also how the chemists actually determine the percentage compositions of the various gases in clean air. Besides learning about the composition of air, another important concept is air pollution. Much of the air that we breathe in is not clean, as they have already been polluted. Pollution is the condition in which the air contains a high concentration of certain chemicals that can harm living or non-living things, and such substances are called air pollutants. If you recall, Singapore has also been affected by air pollution greatly over the past few years. Therefore, it is important for us to understand what causes air pollution and what are some of the harmful impacts of air pollution. In your syllabus, there is a total of 6 key air pollutants that you must know. Firstly, there is sulfur dioxide. Sulfur dioxide is produced when coal and petroleum are burned to generate electricity. This is because these fuels often contain sulfur as an impurity. Besides that, sulfur dioxide can also be produced naturally during volcanic eruptions. Next, there are the oxides of nitrogen. The formation of such pollutant actually requires high temperatures. Therefore, the nitrogen monoxide and nitrogen dioxides are usually formed when coal and petroleum are burned to generate electricity in industries, or when petrol is burnt in vehicle engines and the oxides of nitrogen are released by the exhaust pipes. It is also possible for oxides of nitrogen to be formed by natural processes such as lightning activities. The third air pollutant is carbon monoxide. Carbon monoxide is a gas that is produced from the incomplete combustion of carbon-containing substances in motor engines. It is extremely dangerous as it is both odorless and colorless, therefore there is no warning of its presence. The fourth air pollutant is unburned hydrocarbons, which comes mainly from hydrocarbons in fuels that have not been burned in vehicle engines. Next, there is methane, which is produced when plant and animal decay, as well as from cow and other farm animals. Last but not least, there is ozone. Ozone is a type of oxygen which is formed when sunlight acts on the other air pollutants such as nitrogen dioxide, carbon monoxide, and hydrocarbons. So as you can see, these are the 6 key air pollutants, and their causes can be classified into both either man-made or by natural causes. Among these air pollutants, sulfur dioxides and nitrogen dioxides are the main ones that can result in acid rains. So what exactly is acid rain? Acid rain refers to any rainfall that has a pH of less than 5. Let us now take a look at the formation of acid rain. Firstly, sulfur dioxide and nitrogen dioxides are produced when coal and petroleum are burned in industries. As these two gases are acidic, they can react with oxygen and water in the atmosphere to form acids. So these are two key equations that you must take note of. Firstly, sulfur dioxide can react with oxygen and water to form sulfuric acid. Secondly, nitrogen dioxide can also react with oxygen and water, but this time around to form nitric acids. When these two acids dissolve in rainwater, acid rain is formed. So when acid rain falls, it can actually result in many harmful effects both for the living as well as the non-living things. Let's take a look at what are some of the effects of acid rains. Firstly, acid rain can destroy plants by making the soil too acidic. As you can see over here, the root growth is dependent on the acidity of the soil itself. Next, acid rain can also kill marine life by making the habitat unsuitable for life. Third, acid rain can cause metals to corrode faster. Acid rain can also corrode buildings and objects that are made of calcium carbonate, as you can see in this statue over here. Last but not least, acid rains can damage trees and also destroy important habitats for living organisms. Well, now, the thing that we should ask ourselves is that what can we do to reduce the chances of acid rain happening? The first thing that we can do is to use fuels that contain little or no sulfur. This will in turn prevent sulfur dioxide from forming. Secondly, we can also use catalytic converters, which will reduce the amount of oxides of nitrogen that are released into the air. And this is in fact found in many modern vehicles right now. Last but not least, we can add slick lime to soil or calcium carbonate to lakes or soil for neutralization. And these are just some of the ways that we can help and do to prevent acid rain from happening. So right now I have a question for you. Assuming that the soil has been affected by sulfuric acid, how would the addition of slick lime or calcium carbonate help? Construct a balanced chemical equation for the reaction that is involved. And with this, we have come to the end of the online lesson on air.